Hi everyone, I am Pravallika Patruni and in this presentation I will be teaching how to solve question 5 from benchmarking clinician's assignment. This presentation is a part of TeachOne assignment for HAP823 Causal Analysis and Comparative Effectiveness course taught by Professor Alemi at George Mason University. So before we solve the question, I would like to go over some basic concepts for better understanding of our topic. What is benchmarking? It is a process by which an organization can measure and compare the outcome of processes with fellow organizations belonging to the same field. And its purpose is to improve efficiency, quality of care, patient safety, and satisfaction. There are two types of benchmarking. Internal benchmarking, which is done within the organization, and comparative benchmarking, which is done between the organization and its peers. So why to balance the data? Benchmarking involves data balancing for accurate comparison and to overcome concerns with differences in patient population. These are the following steps involved in data balancing. In step 1, patient population is described in terms of their features, comorbidities, or we can say covariates, and each combination is a separate patient type. These combinations are then used to calculate patient distribution of clinicians and their peers, and the expected outcomes are calculated for both the groups, and then distribution is switched between the groups and overlapping or matching is calculated. In final step, the unmatched cases are replaced by synthetic cases through synthetic minority oversampling technique. And this is how we can actually construct the synthetic case. So excluding a portion of the data that is not matched might result in loss of detail and accuracy in benchmarking results. Therefore, it is at most necessary to construct synthetic cases to replace missing patient outcomes. Not all the missing outcomes need to be replaced. Cases where clinician misses patient types seen by the peers can be ignored as they do not affect the outcome. Synthetic cases can be constructed by many methods, for example, assumption of independence, regression method, etc. Now we'll go into the question. So here is our question. The following data show the recovery from various disabilities in 2 nursing homes. 2 sets of data are presented. The first set shows the disability of the patient at admission to the nursing home using variables that start with U standing for unable. The recovery from the disabilities is also shown in variables that start with R. Compare the performance of these 2 nursing homes using distribution switch method. In particular, switch the distribution for age, gender, and 9 disabilities on admission. The outcome of interest is the number of disabilities recovered from, which is shown as a variable N recovery. Use synthetic method to estimate outcome for cases not present in both nursing homes. Which nursing home has better outcome for its own residents? What happens if residents at nursing home A were cared for at nursing home B? Which nursing home would have better outcomes now? What will happen if the reverse happens? So let's go over the data. We have ID, age, nursing homes A and B here, and sex, and all the 9 disabilities and 9 recoveries, along with survival, which is dead or no, and this is the outcome variable recovery. So our question asks us to switch the distribution for age, gender, and 9 disabilities on admission. So we might only need age, the nursing home, the sex, and 9 disabilities. And this N recovery, the outcome variable, is the summary of all the recoveries, the 9 recoveries here. So we can actually omit this while we are importing or while casting the data. So the first step is casting the variables. Here I cast age as float, and I converted all the variables into binary along with the sex, and and I kept this into a table called nursing caste. And then I grouped age for my ease of use, and I found probability using this query. So I divided age into 4 age groups this way, and after finding probability, I kept this into the nursing final table, and this is how it looks. This is the probability, and I calculated the number of patients and the recovery and all the 9 disabilities along with different nursing homes and sex and age. And then I calculated the pattern of care for nursing home A separately and nursing home B separately. So this is how the SQL output of a pattern of care for nursing home A and B looks. And then I matched the nursing homes on the common strata, which is the age, sex, and 9 disabilities. And then I kept this into a temp table called match. This is how the matching table looks. Here you can see the null values in nursing home A and null values in nursing home B as well. So generally, we only consider constructing synthetic case for benchmarking nursing homes or nursing home in focus. But in our question, we construct synthetic case for null values from both the nursing homes as we are comparing performances of both the groups simultaneously. So all the null values from nursing home A has only one patient. All the null values in the nursing home A has only one patient in the nursing home B, and almost all the nursing homes, the null values in the nursing home B has mostly one patient in nursing home A. So these are the rare cases which we can actually filter furthermore. So this is the query, and in this query I actually removed the nursing homes, the null values which has less than 2 patients from the opposite or peer nursing home, which might be A or B. And then I filtered only the null cases so that I can clearly see what are the synthetic cases I have to build up. So this is the SQL output of filtered or unmatched cases. I have one case in nursing home A, which is the null in nursing home A, and 3 cases in nursing home B, which is the 3 nulls in nursing home B. So I have to construct a synthetic case on these particular null values. So how do I construct a synthetic case? As you can see, this particular null value has age group 25 to 50 and sex male and disabilities toilet, bathe and dress. And these null values have these corresponding covariates. So I wrote a query. I wrote a condition where the covariates actually match to these particular null value covariates. So I have one case from nursing home A and 3 cases from nursing home B. So I wrote one condition for nursing home A and 3 conditions for nursing home B. And I kept all these into all matched temp table. And then I checked if I left any nulls unattended, which means I want to make sure I did not miss any null values so that I did not miss any construction of synthetic case. And then I found no cases with null values, and this is how the data looks. And then I compared the performances of nursing home A and B separately using this query. And here we can clearly see this is the recovered number of disabilities of nursing home of patients A and B which are treated by nursing home A, and these are number of recovered disabilities of nursing home A and B treated by nursing home B. Clearly, we can see that nursing home A is performing better on its own patients and on the peers patients, but nursing home B is performing better on the peers patients than its own patients. We can also see the comparative recovery rate of both nursing homes using this query, and the comparative recovery rate is better for nursing home A. So here are the conclusions. The overall performance of nursing home A is better than nursing home B. Nursing home A performs better on its own patients as well as B patients. If nursing home A patients were cared for at nursing home B, the number of recovered disabilities is more. That is, B performs better on A's patients compared to its own patients. If nursing home A cares for nursing home B patients, the number of disabilities recovered is better compared to nursing home B caring for its own patients. That is, patients of hospital B have better chance of being cured by nursing home A than nursing home B. So that ends my presentation. Thank you for watching, and if you have any further questions, please feel free to comment below this video. Have a good day.